The special part of this BoeBot is that observing that there were QTIs and multiple types of infrared detectors, I thought I would build my own. The infrared detectors are underneath, and if I tip this up to show them to you, they're right there. It's amazing on the camera that it shows the infrared signal coming out of the diodes, and all of them are just on all the time rather than trying to pulse it. That was a nice thing about building my own board. I could shield it from light, and also these modules that I purchased, I believe they're CT5000s. They're about a quarter piece, and they have shielding in them for sunlight for the photodetectors, and that's the other part of the detector that's not glowing. So there's 8 of them, and they produce the infrared light. The ones that white paper reflects it, and the dark line doesn't reflect as well. And so if we shift over the paper, we can see how it dims a little bit as it hits the black line versus the white line. What it does is this other chip is a multiplexer that will take 8 inputs and put it into 3 lines. The CPU selects which one it wants to see and checks only the lines it wants to, so that it can do different things with the line. So for example, if it sees all dark lines, say by lifting it like this, it says that somebody's picked it up, so it stops moving. And it can be programmed for several different things. As it gradually sees lines change, it shifts the speeds a little bit. If it sees a lot of change like that, it hits it really hard. The other thing it do, if it sees right angles where only half of them are lit and half of them are dim, it'll make right angle changes and pivot. So there's a lot of uses for that, and that's how this one works. And the purpose of explaining how all this works is for the 2013 BoeBot Parade, we're going to modify this to have some more fun with it. The way the obstruction control works is by means of a ping sensor. The ping sensor is right there. It is aimed down to try and keep it from having an infinite space to try and measure. So during other trial and errors, I found that if it waited too long and it was in the motor control circuit, it would delay it. So to speed things up, it was always measuring some value that was greater than infinity. So remove that, and to another demo we can show that it's not pinging that far out. That as I bring its coconut into range, that's about where it triggers. There's also measurement in there to make sure that if it gets too close that it doesn't see zeros. Okay, the neat thing about the BoeBot is it has a switch that disables the servo, so I could do this test without it moving. For the 2012 BoeBot Parade, this was my entry built on a BoeBot chassis for doing line following. The rules for the BoeBot Parade are it needs to follow the black line and also have a sensor so it doesn't run into the robot in front of it in case the parade has a stoppage. The parade restarts, the BoeBot should start back on its own. So just to do a quick demo of it in operation, I'm going to click it on, and there it goes, following the black line. When it detects an obstruction, it stops, and it flashes a flashing light to indicate that that's the reason it stopped. We remove the obstruction, it continues on its way. Well, now we're going to get into the basics of the 2013 version of the BoeBot line follower for the BoeBot Parade. Now to get started, the plexiglass cover that was on top, this is normally the BoeBot right here. I added extenders for the parade. Of course, there's a relay card I hand built for the back that lights the lights. And I've left the line follower module attached to the front. We're going to just leave that there because that's a good spot for it. Pink sensor has been removed. The harness is sitting there. What we're going to do is we're going to replace this upper shield. The upper plate that was made out of plexiglass, and we're going to replace it with something a little bit bigger. And that's what we're going to show you right here, and I'll bet everyone can guess what this is going to end up being. We're going to replace the top with a bigger top. Now this top is much bigger than the old one. It's a plexiglass sheet. We can follow it was cut in shapes. It was cut into a long piece here, and for the nose, and then it was bent in a plexiglass sheet bending machine. It's manual, but it still needs something to be able to keep the line straight. And it was cut in a way so that it looks like a steam engine. Now, after the sheet was cut, made a boiler tank. I did not have the foresight to start recording how I did it beforehand, but the boiler tank for the steam train is nothing but a Coke can, and it is painted black. The front end of it is very interesting. That is a bottle cap, and I put an LED, white LED in the front as a headlight, put the bottle cap in the front of the Coke can, and this smokestack is actually just a PVC pipe, part of an old marshmallow gun. It's put in through the top and it goes to the bottom to keep it rigid. So that Coke can was painted, and it really looks pretty darn good as a start. And then I gave it a name. The name of this BoeBot this year is the Parade Princess. And there's the club logo on the side. So that's the start of the shield. Well, here's a picture of the BoeBot with the line follower module with the new top on it made out of plexiglass that has a platform on the top for mounting a whole bunch of other new stuff, new features, the boiler tank, and a place for the cow catcher. Now the cow catcher is also going to have the ping sensor. The ping sensor is not installed. The harness is still sitting here. What we want to do is install pieces that we make a little bit of a time and test them. We can also see right here that the BoeBot right now is nose heavy, but that's okay because that's not going to last forever. We're just going to run a quick test on it and see what it looks like. And there it keeps running, it's bouncing around. That's actually kind of cool for a steam engine. Woo! Another part of the 2013 steam engine BoeBot is going to have an upgrade and have its own sound system, which is going to be cool for sound effects. Now here is the staging of it. It's a WTV020-SD-16P sound chip with a micro SD card. I've used those on my other projects, but this time I hooked it up differently. Rather than having a hardware control on it, I do have it hooked to a Arduino for serial line control. Similar also to other projects, the output of the WTV20 is hooked to this small amplifier. This is actually a 15 watt per side amplifier. I've hooked that up and I've sawed off the heatsink in half because for this effect I don't need a huge lot of heatsink. It won't be running for that long. The beautiful part, here's a mounting for a pair of speakers. These are 10 watt 2-inch speakers. They're very small and they sound pretty good though. And I just laid them there temporarily. And all the hookup wiring is done with alligator clips. And it kind of looks like a mess right now, but if you'll come up one at a time, it's not too bad. The input's coming into the amplifier from the sound card. Now the interesting thing is there's battery packs for the power. So what we're going to do is we're going to turn it on. We'll see. Although we've got a steam engine, sounds like a car starting up. Arduino. Ah, there we have a steam engine sound. And it'll keep running the same loop. Now what we have too is there's going to be some sound changes. I have them hardwired. If I disconnect it and hook it up to 5 volts, so that siren will go off on different parts of it, and we're going to have all kinds of different sound effects, and they'll be triggered from the BoeBot controller, be hardwired to the Arduino. The Arduino will control the sound chip. So looking forward to mounting all this onto the BoeBot and have a very interesting steam engine for the parade. Always the next step in the design is to keep checking and doing things in small steps. The sound card's been transferred from the proto board hooked to the Arduino over to the proto shield that's mounted directly on the Arduino. That's the final position it's going to be in, and there's been some jumper wires put in there for the connections, and we want to go see and hook it up again and double check to make sure everything still works, so we have time to go back and fix things before we get too far along with the design. One of the things we'd like to mention is I did have a little problem that I had copied the schematics from the specification sheet of the chip about how to hook it up. The Arduino software, on the other hand, was written very similar but a little bit different. And what I had done, I have a notebook that I keep for recording all the things that I do in all my projects. We can see that I had swapped 2 pins because I had copied them off the spec sheet, forgetting that the software used them differently. So they had me devote some troubleshooting time. So what we're going to do here is we've got a small power supply for the Arduino. The shield is now strapped on the Arduino, and we'll plug it in. Well, it's pretty cool. Everything seems to be working pretty well. We've proven out this part of the circuit. We can move on. There's a second circuit added to this proto board. I'll explain a little bit before we test it. I had tested it already a little bit and transferred it to this board. What we have, this is a MOSFET. The sound card is running off of 3.3 volts supplied by the Arduino. The Arduino is going to be supplied with 12 volts, and the power amplifier for the speaker is also from a 12 volt supply. The main supply here for the BoeBot is controlled from a parallax BoeBot controller proto board. So we have a separate controller here for the sound card and the auxiliaries. I don't want to have to turn on 2 different switches. So what I have done is added a place to wire in the 12 volt power supply. It goes through the MOSFET. The MOSFET is going to be triggered by the BoeBot supply after it boots up to turn the power on to the amplifier into this Arduino. That way the BoeBot has control. This has some time for the BoeBot boot up before the sound starts, and what we'd like to do is have the states of the BoeBot set before it tells the Arduino what to do. So that's what we're going to demonstrate here now, is the MOSFET circuit. Okay, now what I've done here is built a circuit that takes 12 volts into here. It references common to one point, and the plus part of the power supply, which is 12 volts, just like this prototype board, to here. Now the purpose of bringing both of those in, number one, was to get the battery power supply for the 12 volts referenced to the same points as the Arduino and the sound card, so everybody's working from the same reference point of 0 volts. And it also makes the hooking up very much easier if I can just bring in a pair of points from a battery. That is what these 2 points are. Then I've wired it up so that this point here is also 12 volts. That's the same 12 volts as comes up here. It just makes the hook up easier, which in any of your projects you want to think about how you're going to wire things up to make it easier to plug things in and out. The lower half of this is hooked to the common, and what I did was I just put a simple LED here, just like it was a load circuit for 12 volts here and common here. This is not truly common yet, though. There is a MOSFET between it and common, and the idea is when we power up, the battery pack can stay powered, but as the BoeBot powers down, it'll shut this off, so we have an automatic switch. So we're going to try a demo here and see what happens when we turn on the power. Nothing, but that's good. We have 12 volts here, and we don't have any 12 volts there yet because we haven't triggered it. Now one of the things we do to trigger it is we'll just tie that point to 5 volts, and there's a little trigger pin over here right behind here so I can hook to it, and it didn't even take me 5 volts. That MOSFET is so sensitive it triggered off my fingertip. I have a 150 ohm resistor in series with the gate of that MOSFET, so there's no reason to worry about touching it. The power supply is already. If I ground it, it turns it off, so it works just like a switch. So we'll try that again. This time, instead of hooking with my finger for noise, I just hooked a 5 volt supply and it turns it off and on. So that's kind of a nice thing to do, a solid state switch. And after you have it done for this, now you know how to do it for everything. Turn it off by grounding it. So it's kind of neat how that works. It's actually latching on, and we don't have to keep turning it off and on. When you get to other switching applications like driving motors, you can use the exact same MOSFET. And actually that MOSFET is a 44 amp MOSFET, believe it or not, that little package. So you can drive a lot with it. Most of the losses are not in the on state, it's when it transitions off and on. That's another lesson. So we've gone through and tested our circuits. Now we're ready to move them on to the Parade Princess. A word about the ping sensor. The ping sensor is used to measure the distance to the robot in front of you, and whenever it gets close enough within a range that you can determine yourself, then you will stop the robot's motion for the robot parade and wait till it restarts again, and then once it gets within the range or out of the range that you're looking for, then you can tell it to go again. Now what we have here for the connections is there are 4 pins for the ping sensor. The red wire is for power, and the green one is for the ground signal. The other 2, the blue one is for the ping sensor's output, and the other one's the input. The blue is the input to the ping sensor, and the brown one is the output from the ping sensor. Really what it is there is an output from the BoeBot to the ping sensor that tells it to make a ping, and then you immediately read it back on the input side, and this is for this sensor, the HR502. So what I've done is to put it right in the front. And to make it look really cool, here's the ping sensor. I built a cow catcher around it. So I had to start off by building a frame, then putting the ping sensor and mounting it, and then continue to build the cow catcher around it. So that way, way up in front, we go sideways here, we can see as we approach it, we get to a certain distance and it'll stop. And if we go out of the distance, it'll go again, right in the software. Now to interface the BoeBot control, which is controlling the motor, the direction, and the speed of the motors using the line follower and the ping. Coming out of the BoeBot are three outputs. These are the three wires here going down there. And they're coming up to the Arduino right here. Now what those three signals are used for is to play different sound effects based on if it's turning, if it's stopped because it's detected an obstruction in the road, or if it's stopped by someone lifting it off the track. So we'll give it a shot here to see how all that stuff works on the first trial run. Okay, so we're getting ready for the first trial run of the robot parade entry of the BoeBot controller with an Arduino controller for the sound. So we're going to quickly turn it on. Let's see how the avoidance system works. Oops. And of course, it's not quite running quite right yet, but it looks like it's getting there. It's got some cool stuff to it.